Hey everyone, welcome to The Explainer, brought to you by Forge College. Now, if you hung out with us for our last lesson on modular design and designing for auditability, you know we spent a lot of time breaking a monolithic Solana program down into these beautiful, clean, isolated modules. But let's be painfully honest here for a second. Right now, all that beautiful code is basically just a pile of fancy, incredibly expensive bricks. So today, we're taking those abstract bricks and figuring out how to actually build the house. We're getting right into planning and scoping the Capstone project.
All right, let's take a quick look at our agenda, which is basically our own project blueprint for today. We're going to hit the architecture hangover, the blueprint, construction, and handover stages, a 6-step workflow, scoping a matching engine, the mainnet readiness gate, and then we'll wrap up the blueprint. Let's dive right in.
So part 1, the architecture hangover, transitioning from design to execution.
You know, you probably feel absolutely fantastic about those whiteboard diagrams we just mapped out. But then, Monday morning hits, right? And suddenly we face the incredibly daunting task of actually building the thing without totally losing our minds. This is exactly where project planning comes in to save the day. It acts as the bridge. Sure, abstract designs like module interfaces, explicit account boundaries, event schemas, and our CPI or cross-program invocation patterns, they're all absolutely critical, but they are just concepts. Effective planning takes these abstract concepts and turns them into a concrete sequence of implementable work and verifiable milestones.
Moving on to part 2, blueprint, construction, and handover. This is our 3-stage mental model.
If we really want to regain control of our project, we have to start treating software development exactly like a physical engineering project. Think about it. You wouldn't frame the walls of a house before inspecting the foundation, right? So what's really interesting here is how we map abstract planning categories into highly tangible deliverables. In the blueprint stage, we are measuring clarity using concrete artifacts like our account layouts and IDLs, those interface description languages. Then in construction, we measure correctness using unit tests and mocked CPIs. And finally, in handover, we measure verifiability through operator runbooks and docs. This guarantees we're measuring the right kind of success at every single phase, rather than just constantly asking, hey, is it done yet?
Now, I really want you to internalize this core philosophy. Translate architecture into incremental work, and translate incremental work into verifiable evidence. Seriously, let that sink in. This philosophy is the magic trick that turns a clean but highly subjective design floating around in your head into a credible capstone deliverable that external reviewers can actually evaluate objectively. Because at the end of the day, it's never just about what you built. It's about what you can definitively prove you built.
All right, part 3, the 6-step workflow. This is a practical, repeatable scoping process. So, this is where the rubber really meets the road. Let's look at how this builds into an actionable 6-step workflow that you can actually commit to source control. 1. Identify core user stories. 2. Map features to modules. 3. Define your milestones. 4. Attach verification artifacts. 5. Prioritize dependencies. And 6. Schedule that mainnet readiness gate. By following these explicit steps, literally like an assembly instruction manual, you convert these vague promises of, oh yeah, feature implemented, into reproducible, undeniable evidence.
Which brings us to part 4, scoping a matching engine. This is our CPI-heavy prototype. To ground all of this theory in reality, let's look at scoping out a complex, modular matching engine that routes orders and relies heavily on an external pricing oracle. Before we even think about writing a single line of code, we are immediately faced with a massive question. How do we actually scope a CPI-heavy engine? Think about it. If an external oracle goes down or spits back malformed data during high-frequency transactions, your program absolutely has to manage that risk safely and gracefully.
And the answer to that starts with identifying our core user stories. We're looking at limit order flows like order placed and matched events, conditional orders via an oracle utilizing CPI validation, and bulk canceling under high-frequency conditions where compute budget constraints are a real issue. This brilliantly illustrates exactly why we write vertical user journeys first. It forces us to exercise the absolute hardest parts of the program right away. We're attacking those compute budget constraints head-on day 1, rather than taking the easy road and starting with simple state initialization. From there, we define our milestones. Notice how milestone A, our blueprint, establishes all the interface rules. We're talking IDLs, getting peer review on event contracts all before the heavy coding even begins. Meanwhile, milestone B is our construction phase, where we implement the actual logic. And we do this using a mocked CPI harness to simulate oracle responses perfectly. You absolutely, under no circumstances, want to rely on some flaky DevNet oracle when you're just trying to get your unit tests to pass. And then, finally, we hit milestone C, handover. This stage requires strict, tangible deliverables, stress integration test logs, benchmark logs, an audit summary document, and an operator runbook loaded with rollback commands. Milestone C is all about proving the system works under immense pressure and writing out the operational documentation that, fingers crossed, someone other than just your auditor will actually read.
Let's step into Part 5, the mainnet readiness gate. These are your objective deployment constraints.
This brings us to a topic that definitely keeps a lot of developers up at night. But let's be real here. Absolutely nothing cures the blind panic of a mainnet deployment quite like a ruthless, highly objective checklist standing right between you and the launch button. A mainnet readiness gate is exactly that. It's an objective checklist requiring specific named artifacts and successful test passes before any milestone can actually claim to be done. Think of this gate as a giant stamped engineering threshold. If the evidence isn't there, the code does not ship, period.
So, what exactly goes into this readiness checklist? Well, we need passing integration test suites, fully documented event schemas, a successful dry run upgrade, and a rock-solid operations rollback plan. You must schedule these stress tests and integration passes early. Discovering that you desperately need a rollback plan during a live, burning emergency on mainnet is an absolutely terrible learning experience. Believe me, you want to figure out your rollback strategy on a local validator first.
And that brings us to Part 6, wrapping up the blueprint, transforming code into evidence.
As we start wrapping up our blueprint today, I want you to remember that project planning is entirely about making your capstone both practically implementable for you and easily reviewable for others. To succeed here, you need to cultivate some essential habits. Break your work down into small, verifiable milestones. Don't just say, the tests pass. Name the specific CI jobs or test scripts. Document minimal reproduction steps, and assemble those external program dependencies. Building the habit of naming exact CI jobs will materially reduce your risk and perfectly satisfy those intense auditability expectations.
Looking ahead to our next lesson, we are going to take all these blueprint artifacts you just planned out, and we'll design the exact integration test suites and harnesses to validate our Solana program. We're going to take this theoretical blueprint and start wiring up the actual testing infrastructure to prove that our program is completely bulletproof.
So I'll leave you with this final provocative thought. Is your architecture ready to become verifiable evidence? It is time to translate those brilliant whiteboard ideas into hard, objective proof. Start drafting your blueprints today. And hey, make sure to visit forge.college to dive even deeper into this subject and continue your Web3 journey. Thanks so much for hanging out with me on behalf of Forge College, and I will catch you in the next explainer.